1,300 years. At about 11,600 years ago, it ended. Now, what's interesting about this, about the Younger Dryas period, is that it's almost bookmarked with two catastrophes. The catastrophe at 11,600 years ago is still kind of undefined. There's been no, to my knowledge, evidence of any kind of extraterrestrial impact. However, there was a massive pulse of melting that occurred. And so it's referred to as meltwater pulse 1B. Now, there was a meltwater pulse 1A that is now dated at 14,600. And there's evidence now emerging that there was also a major melting event at the beginning of the Younger Dryas. But it was so quick before the planet jumped back into full glacial cold that it's kind of been overlooked. So anyways, what's interesting about meltwater pulse 1B, that's 11,600 years ago. Now, that is now given as the definition between the Pleistocene, which was two and a half million years, which was differentiated from the previous Pliocene, because in the Pleistocene epoch, what characterizes this epoch is the planet started lurching back and forth between the glacial and interglacial ages, right? So at the end of the Pleistocene, we get into the Holocene. Holocene is now, the onset of the Holocene is dated 11,600 years ago. And shortly within a millennia to 2 millennia after that is when we begin to see the rise of what eventually led to modern civilization. We see the domestication of animals. We see the major shift in lifestyles from mostly, if not all, hunter-gatherers now into a agricultural-based lifestyle. So we see really the rise of agriculture in those 2 millennia after the beginning of the Holocene. What else? Oh, the dispersion of languages generally traces back to around roughly 10,000 years ago. What else? The rise of urban areas. The first Çatalhöyük and Jericho and other cities like that are showing up between 8,000 and 9,000 years ago. So basically all the accoutrements of civilization that eventually led to, what we think of as modern history, 4,500 to 5,000 years ago, all sort of got launched in this post Younger Dryas epoch, if you will. So the question is what caused these tremendous sea level rise? And I think in one of our previous interviews, I actually pulled up a graph where you could see that these two great spikes of meltwater. Rather than it being tens of thousands of years in a smooth curve, it was two major spikes of meltwater. So in order to trigger that melting, you had to have some kind of input of energy. It takes energy to melt ice. So one of the mysteries that actually began to be noticed in the early 70s was what is called the energy paradox. Now, with the advent of radiocarbon dating in the 1950s, what happened is you accumulated a couple of decades of radiocarbon dating. After a couple of decades, the geologists and the climatologists and so on, they're looking at that data and they're going, wait a second, our old models of glacial, the onset of a glacial period, the termination of a glacial period, were tens of thousands of years, 50, 60, 70,000 years. Radiocarbon dating is now showing it happened way, way faster than that. For example, radiocarbon dating showed that in central area of Canada, where it was assumed that there had been a mile and a half of ice, forests were growing, like 30,000, 35,000 years ago. Well, clearly there was no ice there when the forests are growing there, right? The other thing was the rapidity with which the whole thing came to an end. Rather than 15, 20, 25,000 years, it was more like 3, 4, 5,000 years. So this is what introduced the concept of the energy paradox. Like, where the hell did all the energy come from to melt that much ice? And so there was a group of scientists that held a conference in 1973, didn't resolve it, held another conference in 1975, still didn't resolve it. What they were looking at, they go, okay, well, what is the greatest concentration of available thermal energy on the planet today to melt ice? So they said, well, it looks like it's equatorial regions over equatorial oceans. Okay, so if we applied that much thermal energy to these ice sheets, how long would it take to melt? 20 to 25,000 years to completely melt away. So that was the energy paradox. And it really has not been resolved to this day. And see, the assumption was that the energy would have applied in a uniform manner from the beginning of the start of the deglaciation to the end of the deglaciation. But it didn't happen that way. It happened in pulses. So in other words, even though you have a tremendously enlarged amount of energy to melt this ice, basically it didn't happen smoothly. It was concentrated into several episodes, which means then that you have even more thermal energy to try to explain. So it kind of got left there. And of course, then I encountered that. I mean, I guess, going way back in the late 70s, early 80s, when I first got obsessed with the catastrophic history of this planet and geology and all of that, that's when I read these papers. And I kind of thought, well, what's the possibility? It's got to be impacts or it's got to be the sun. What else could it be? There's no intrinsic source of that much heat to melt the ice that quick. So I was very gratified when in 2007 the paper came out proposing that there had been an impact at the Younger Dryas, triggering the Younger Dryas, and we talked about that with Graham on here, and that's actually what inspired Graham to come back to his original idea that he had proposed in Fingerprints of the Gods back in 95 or 96, was the two things: the discovery of Göbekli Tepe, which is back 11,500 years old, right, and the evidence that there had been this cometary impact. So in his Fingerprints of the Gods, he was still thinking, had documented tremendous amount of evidence for catastrophe. But what he wasn't thinking, he was thinking more in terms of the scenario or the models of Charles Hapgood, who was thinking in terms of pole shift. Well, that idea kind of fell by the wayside because it wasn't making sense from the geophysical standpoint and a lot of reasons. But then when 2007 came along and this paper came out, Graham was pretty much electrified when he saw that and said, well, there's the catastrophe. It was an impact, and why didn't I think of that? He probably did, but